For today's lesson, I'm going to ask you to divide your note-taking template, or kind of this area over here, into two parts. So right in the middle of the grid area, I want you to draw a line across just to kind of divide it in half. So take a second, go ahead and divide that in half. You can pause the video if you need to. And then what we're going to talk about today is measurement. Now I'm going to ask that you take this chart, and in that top half of where you divided your notes, in that top section, so that's where you'll need to record these notes. So if you are someone who can listen and write, you can keep this video going because I want to talk through each of these. But if you're someone who has a hard time listening and writing at the same time, you might want to pause the video, draw this chart, copy down the notes, and then hit play when you're ready to listen again. Or you could listen first, pause when I'm done, and then copy down the chart, whichever one works best for you. So in science, we never really just use numbers by themselves. They always have to have something to go with them. Like if I say 3, what does that mean? Well, 3 meters means something else. 3 feet means something else. 3 degrees means something else. And so in physics, we have to agree on a common measurement system. And we're going to start out discussing that common measurement system by talking about basic measurements. Those basic measurements are length, volume, and mass. Later on in semester 2, we're going to measure other things besides length, volume, and mass, but this will get you through most of semester 1. Let's start with length. Length is how long something is. So if I wanted to measure how big my desk is in one dimension, that would be the length. So if you imagine this box that I'm drawing as a desk, if I wanted to measure the length, this is the part right here that I would measure, the length. Other things you can measure, other lengths you can measure, the height of a person, the distance between school and home, how big a lamp is. Right? Next up, volume. That's how much space an object takes up. So if you've got a can, and you don't just want to know how tall it is, that would be a length measurement, but you want to know how much stuff is inside of that can. So if I want to know how much stuff is in that can, how much space does that take up? That'd be volume. Other things you can measure with volume are the amount of water in a bathtub, amount of soup in a can. Next up is mass, which a lot of people confuse with weight. Mass is not how heavy something is, it's how much matter, how much stuff is in something. And that word stuff really is the best way to describe it. How much stuff is in you is your mass. And something we can talk about, the mass of a car, the mass of a person, all how much matter is in that thing that we're talking about. So if you are taking notes, I suggest you pause the video right now and catch up on your notes, because I'm going to move on to the next slide. So if you need to, go ahead and pause the video here. Now let's talk about the actual units. So like earlier I mentioned 3 meters, 3 inches. Let's talk about what we can actually do with measurements. There are 2 main systems of measurement that we use in the United States. The first one is the English system. And the English system is what you're probably used to. Inches, feet, yards, miles, teaspoons for volume, ounces, cups, quarts, gallons. In science, though, we use what's called the metric system. So this is the method in science. The English system is used mainly in former British colonies. So Britain, the United States, former British colonies usually use the English system. But in general, the world, and most of Europe specifically, uses the metric system. And it is the agreed upon measurement system in science. All scientists worldwide agree we should use the metric system. So these measurements, these units down here, those are the ones we've agreed to. Before I really talk more about that, I want to point out something to you. Over there in the mass section, right here, pounds and tons. These are not actually units of mass. They are units of weight. But in the English system, we really don't ever use the measurement for mass. There is an English measurement for mass. It's called a slug. So that's the actual English measurement for mass. But no one's ever said, I need 3 slugs of corn. It's pounds. We use pounds in the English system, which is actually weight. Pounds tell you how heavy something is. Now, in the metric system, we've got grams, milligrams, centigrams, kilograms. Those tell you how much matter are in something. Grams, milligrams, centigrams, kilograms. The main ones you'll hear me use in this class are grams, kilograms. Milligrams gets used sometimes. Centigrams, hardly ever used. It's meaningful. It means 1/100th of a gram, but nobody really ever talks about centigrams. So what I want you to do now, this chart that I just talked my way through should be on the bottom half of your notes. So the charts from the last slide I was talking about, top half, this chart, bottom half. If you need to take a second to copy this down, please pause the video now. Okay, now that you've got your notes down, I want you to look over at that meta notes column. This is what we're going to talk about for a second. Make sure everybody gets it. I want you to think back as you were taking notes on these 2 charts and write what you were thinking, what you were feeling as you went through. Like if you want to say, Mr. Melvin, I really wish you hadn't talked that fast during this part. I didn't get that down. Or I wish you told me we were copying down this second chart beforehand. Or I had to rewind the video 3 times here. I'm still confused about this part. Meta notes is what you were thinking, what you were feeling over there on the left. That way I can know how the videos are working for you, also have your own opinion on what you know. That's what I'm going to be looking for there. What do you know? What did you get? What did you not get? What was hard? What was easy? So go ahead and pause the video again and take a second to do the meta notes. Alright, now that you've done the meta notes, I'm going to tell you a little story. Not very long ago at NASA, 2 teams of scientists were working on a Mars orbiter, which is basically just a satellite to go to Mars. So we had one team over here. Okay, and we had a second team. The problem was that one team was being good scientists, and they used the metric system. Another team didn't do so well at their scientific training, and they used the English system. What happened was, these guys over here would make some measurements and write them down, send them over here, and assuming that everybody knew to use the metric system like they should, these guys over here were using the metric system. And they were assuming that these guys here were using the metric system. So they were really confused, and they're sending data back and forth. But they were both building parts, and when they came to put the parts together, the Mars orbiter fell apart because some of the parts were too big, some of them were too small. It was all because they weren't using the same measurement system. And so in science, all scientists and all physicists have agreed that we will use the metric system. And it's a common agreement we have. You have to learn the metric system to do science because that is the measurement language that all scientists speak. At this point I want you to pause this video and open up or play the other one that's in this blog post. It's a little video of some British people making some measurements, and then a video of some bicycle repair people in the United States making some measurements. Pretty entertaining. So take a minute to do that. Go ahead and pause this video and play the other one. Come back here when you're done. So now that you've seen kind of an absurd situation that happens when trying to make measurements in the English system, that's what they were doing with their 3 5/8, 9 7/4, and then they tried to subtract those, and everybody's bad with fractions. 6 7/8 minus 5 9/16. What's that? In the metric system, it's far simpler. We use decimals in the metric system, so if I were trying to do the subtraction that they just were, the metric system, it would go something like 3.5 centimeters minus 2.1 centimeters equals 1.4 centimeters. Far simpler than trying to do 9 and 5/16 minus 6 and 7/8 equals, well, maybe I do the 9 and the 6 plus the 5 over the 12, carry the infinity. Yeah, it gets really confusing when you're trying to use the English system to convey measurements to people, and that's why we use the good old metric system. All right, now the point of this slide. I want to talk about some examples of metric units so that you can have them in your head. A gram is about a paperclip. If you have a paperclip near you, please pick that up. You can see what a gram feels like. Paperclip has the mass of a gram. And another kind of neat way to remember it, a nickel is 5 cents. A nickel also has a mass of 5 grams. So you can remember 5 cents, 5 grams, remember a nickel. Kilogram is about 1,000 paper clips. In fact, that's what kilo means. Whenever you see kilo, that means times 1,000. So a kilo of anything is 1,000 of that thing. If you have a textbook nearby, pick it up. That's about a kilogram. And tomorrow in class, I will pass around a kilogram mass so everybody can really feel what a kilogram is like. So you can really experience that tomorrow in class. Otherwise, pick up a book and you'll come pretty close. A liter. You hear this unit all the time, and it really is as simple as the thing you hear all the time. It's a water bottle. If you've got a water bottle, it is probably a liter. Fill it up. You're looking at a liter of water. Kilogram or kiloliter. 1,000 water bottles, somebody's swimming pool is a kiloliter. And we're not talking about the kiddie swimming pools. So we're not talking about these ones that you send baby to go sit in. We're talking about these ones that are super big that you can jump into. So, kiloliter, think of a swimming pool. And remember, a kilo is just 1,000 of these. Some other examples, a meter. If you've ever seen a meter stick, that's a really simple one. Most of you, the students, are 1.5 to 2 meters tall. If you're 6 feet, you're about 2 meters tall. Kilometer is 1,000 meter sticks, or about 500 to 700 students laid head to foot. The distance between, say, our school and the nearest Home Depot would be measured in kilometers. It would actually be a couple kilometers. The track that's at, I think, MLK Field, about 2.5 laps around it, is a kilometer. And note, a kilometer is indeed less than a mile. We should definitely talk about that more as the year goes on, exactly how the two relate, but a kilometer is less than a mile. Next up, a centimeter. It's about the width of your thumb. So if you hold up your thumb, the nail facing you, the width there, not the height, but the width is a centimeter. And then if you hold your thumb sideways and look at how thick your nail is, that is a millimeter. Centa, we'll talk more about this in the next video. Centa means 1 over 100. So a centimeter is 1/100th of a meter. Milla, 1/1000th. So 1/1000th of a meter is a millimeter. And we'll talk more about those later. Alright, you've reached the end of this video, and I'm coming up on my YouTube time limit, so I'm going to go through this fast. Make sure you've done the things on this list before you come to class tomorrow. After reading question, it's in the blog post. Textbook reading, if there is one, I made this video a little early, not sure yet. It's in the blog post if it is, super obvious. Notes page completely filled out. To really participate in the discussion tomorrow, be super familiar with that chart that I had you copy down in your notes. You're not going to have to show me anything on the way in. I'll take up your notes during class. You're going to do a reading quiz just like we talked about earlier today. Nothing to show me in class. Go over those notes, rewatch this video if you need to, and have a good night.